Hey there, today we are talking about section 2.4, which is rates of change and tangent lines. So this will be a warm-up that we will do in class. I'm going to skip it and move on. We are going to learn about average rates of change, tangent to a curve, slope of a curve, and then normal to a curve, and then speed revisited. So your average rate of change of a quantity over a period of time is the amount of change divided by the time it takes. So if you're driving from here to Milwaukee, figure out how many miles you went divided by how long it takes, and that's how you get your average miles per hour. In general, the average rate of change of a function over an interval is the amount of change divided by the length of the interval. Also, average rate of change can be thought of as the slope of the secant line to a curve. So secant line, we did a little bit in the pre-calc stuff, but secant line is just 2 points, and you're just finding the slope of those two, between those 2 points. All right, so average rates of change, we have a function here. We're finding the average rate of change over the interval. So we want to start with, basically, I am finding the slope. So I am putting my -2 in and my 4 in. So I'm doing f of -2 minus f of 4 over -2 minus 4. So plug the values in, simplify, we get 1. So the average rate of change from -2 to 4 would be 1. In calculus, we often want to define the rate at which the value of the function is changing with respect to x at any particular value to the slope of the tangent line of the curve. So the problem with this is that we have 1 point, and our usual definition of slope requires 2 points. So what we want to talk about is we start with what can be calculated, namely the slope of the secant line through P and a point Q nearby on the curve. Finding the limiting value of the secant, so getting that closer and closer to each other. And then define the slope to be this number. Define the tangent to the curve at P to be the line through P with this slope. So what that means is we have this equation, x squared plus 2. We have the value x equals -1. We want to find the slope of the curve and then write an equation of the tangent line, then draw the graph of the curve and the tangent line in the same viewing window. So first thing that we need a slope and we need a point in order to write any equation. So write an expression for the slope of the secant line and find the limiting value of the slope as Q approaches P. So what we are going to do is I'm going to stop here. You are filling in, and they're calling this Y, okay? So P is this point, so your X value is -1. So they did the limit as H approaches 0 of Y of -1 plus H minus Y of -1 all over H. Put that values into the original function. We are going to simplify them. And then we're here, we simplify again, the H's cancel. And then as a limit, the easiest way to find the limit is to substitute. So we put the 0 into the function here, and we end up with -2. So -2 is going to be the slope at that point. And then, of course, we have this point. So we can write the equation of that line because I have slope of -2 and I have this point. We can write the equation. This would have been okay for me. This is going to be easier to graph, so that's why both of them are on there. And then, of course, here was our original function. It is a parabola, and then here is the tangent line at this point. The slope of a curve. To find the tangent to a curve at a point, calculate the slope of the secant line through P and a point a little bit bigger than P, or a little bit smaller, depending on if H is positive or negative. Next, investigate the limit of the slope as h approaches 0. So as that value gets closer and closer and closer to your original, what's the slope? If the limit exists, it is the slope of the curve at P, and we define the tangent at P to be the line through P with this slope. That's a lot of fancy stuff, but really you're just finding the slope at this particular point. So you start with the secant line, okay? And they're h away from each other, but you want h to be getting smaller and smaller and smaller. So eventually it ends up to be right at that value. That's what the limit does. So slope of a curve at a point, here's the definition. We have point P, which is a f of a, and then here is the slope, provided it exists. It could be undefined, of course, vertical line. The tangent to the curve at P is the line through P with the slope. Hey! So if you need this, pause it, write it down. So all of the following mean the same. Slope of y equals f of x at x equals a. The slope of the tangent to y equals f of x at x equals a. The instantaneous rate of change of f of x with respect to x at x equals a. Limit as h approaches 0 of f of a plus h minus f of a all over x. And remember, this guy here is considered the difference quotient. I have asked for that on certain quizzes this year. Normal, the normal is the line through that same point, and it's perpendicular to the tangent line. So opposite reciprocal slope. So we already found this. So this was the same equation that we did earlier. And we found that the slope of the tangent at x equals -1 was -2. So my reciprocal slope is positive 1/2. This was -2. So my reciprocal slope is positive 1/2. And then you're just going through and writing your equations. So I put in -1/3. They simplified because, of course, it's easier to graph this than that. So this was the normal line. This was your original curve. And then, or sorry, this was the tangent line. This guy here is now the normal line, perpendicular to the tangent. Speed revisited. The function y equals x, or 16 times t squared is a function, is an object's position function. An object's average speed along a coordinate axis for a given period of time is the average rate of change of this position. The instantaneous speed at any time is the instantaneous rate of change of position with respect to time at time equals t. So right here. Blah, 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 blah. Okay, so we will do some problems in class, but that is all that we have for this. Thanks, guys.